The knife was visually inspired by the German Monge Messer blade design, scaled down and modified to use locally sourced materials and manufacturing techniques. Safety is critical for any metallurgy work, and blacksmithing is no exception. The Appalachians Blacksmiths Association has published recommendations for blacksmiths to use while forging and working with metal. Safety glasses must be worn at all times when blacksmithing to prevent eye damage from splinters. A blacksmith must wear closed-toed shoes, long pants, and a long-sleeve shirt. Wear clothing made out of cotton or wool, as polyesters and synthetics will catch fire more easily and are harder to douse. It's best not to wear gloves when actively forging. If you pick up hot metal with gloved hands, the chances are that you will be burned worse than if you grab the hot metal barehanded. However, gloves should always be worn while working with close flames, such as using an acetylene torch. Being mindful of safety, and being sure to always wear the appropriate protective gear, makes the rest of any bladesmithing project possible.
The blade was hand-forged using a charcoal furnace for heat. In order to create a blade with functional hardness, the steel was heated up to a critical temperature of 800 degrees Celsius and then quenched into oil. The blade was tempered at 175 degrees Celsius to decrease the brittleness and gain a straw color, and then at 350 degrees Celsius with a propane torch for the blue color.
The handle was designed using Autodesk Inventor and included a dragon scale pattern. The pattern was created to take advantage of the high detail from additive manufacturing with no need for post-production processing. The crossguard, grip, and pommel were binder jet printed by Hagenus in individual pieces and attached via epoxy around the tang of the blade.
At the beginning of the process, the head of the railroad spike was removed and processed in the same way as the blade, with pieces being cut off at each stage of the processing. Rockwell hardness testing and SEM microscopy were performed on each of these samples in order to observe the evolution of the microstructure throughout the process. The initial microstructure of the railroad spike is composed of colonies of perlite in a ferrite matrix, typical of a steel with a carbon content below the eutectoid composition. The hot work performed in the forging process caused work hardening and refinement of the grain size. When the blade was heated above the austenite temperature and then quenched, it formed the metastable phase martensite, which is very hard and brittle. Tempering removes some of the martensite by heating the blade to a temperature high enough to allow diffusion, which enables the martensite to decompose into a more stable phase. This prevents the blade from being too brittle.
We would like to thank our advisors, Dr. Richard Knight, Dr. Mitra Taheri, Matthew Hartshorn, and David Freiberg of the Drexel University Department of Materials Science and Engineering, as well as our support group at GKN Hagenace, George Bernhard, Alex Zwirin, Peter Sokolowski, and Barry Diamond. Thanks also go to Peter Adams of Icarus Forge.